Jai Hind. Welcome to today's class. Today we are going to start the new chapter, straight lines. In earlier classes we studied about two-dimensional coordinate geometry. You know that it is a combination of algebra and geometry. Coordinate geometry was first introduced by the French mathematician René Descartes. Let us have a brief recall of coordinate geometry done in earlier classes. Consider the xy plane. Look at figure 1. Here, I marked the point P32 in the first quadrant. This is the xy plane. You know that the x value of the point P is 3 and the y value or the y coordinate is 2, which means that the distance of the point P from the y-axis, this is the y-axis, from the y-axis, the distance of the point P is 3 units. Why? Because the same distance we can see here. So, distance of the point from the y-axis, distance from the y-axis, distance from y-axis. This is your x coordinate. 3 is the x coordinate. So always remember, distance of a point from the y-axis is its x coordinate. And in the same way, distance of this point from the x-axis, this is the x-axis. From the x-axis, this distance, that is the perpendicular distance, this much is known to as 2 units. Why? Because the same 2 units we need to keep here. So, distance of this point from the x-axis is distance from the x-axis. From the x-axis is 2. Am I right? Distance from the x-axis is 2, which means that it is the y coordinate. So, this is the first and basic point you need to remember in coordinate geometry when locating a point. Distance for any coordinate P, distance of the point from the y-axis is its x coordinate and distance of the point from the x-axis is its y coordinate. Come to figure 2. A very important concept we need to discuss here. Here, x, o, x dash and y, o, y dash be the x and y axis. Consider a line L. This is the line L. Consider a line L which passes through the point 2 in the x-axis. You know that every point in this line has the x coordinate 2. You don't know about the y coordinate. X coordinate clearly we can say that it is 2. Why? Because it passes through 2 in the x-axis. Here also the x coordinate of the point is 2. Here also the x coordinate of the point is 2. Here also the h coordinate of the point 2. Why? Because for each and every, this is the line parallel, the line L is parallel to the y-axis. Here the line L is parallel to the y-axis. As this line is parallel, the distance of the line L from the y-axis, this much distance, is the distance from the y-axis is the x coordinate. So, distance from the y-axis, this much distance is the x coordinate 2. Here also the distance from the y-axis, the x coordinate is 2. That is why I told you that the distance of the point from the y-axis, which is the x coordinate, and this is fixed in the case of this line which passes through 2 in the x-axis. So, here what you can say, distance from the y-axis equal to the x coordinate 2. Now we can recall some important formulae in coordinate geometry. The first one, distance formula, already known for you. The distance between 2 points Px1y1 and Qx2y2 is. Consider 2 points in the Cartesian plane. Let the coordinates be x1, y1 and x2, y2. The distance PQ to find the distance between the points P and Q, the distance formula you can apply. The distance PQ can be found out by using the formula square root of x2 minus x1 the whole square, x2 minus x1 the whole square plus y2 minus y1 the whole square. Or you can arrange it as, or the same formula you can write as root of, instead of x2 minus x1 the whole square, if you want you can write as x1 minus x2 the whole square plus y1 minus y2 the whole square. Let us discuss a problem. Find the distance between the points minus 2, 3 and 6, 7. Here your x1, y1 equals minus 2, 3. You are asked to find the distance between these 2 points. And x2, y2, the second coordinate is given to us 6, 7. Let the point can be taken as A and B. Let A be the point minus 2, 3 and B be the point 6, 7. You are asked to find the distance AB. Distance AB equals square root of, at first you need to write the formula x2 minus x1 the whole square plus y2 minus y1 the whole square, which is equal to square root of, what is the value of x2? x2 is 6 minus x1 is minus 2. 6 minus minus 2. 6 minus minus 2. Here a minus 2, 3. 6 minus minus 2 the whole square plus y2 minus y1. y2 is 7 minus y1 is 3 the whole square equals root of 6 plus 2, 8. 8 square is 64 plus 7 minus 3, 4. 4 square is 16. 64 plus 16 root 80 units is the answer. This is the distance between these 2 points, root 80 units. The second is the section formula, a very important one. Section formula is used to find the coordinate of a point P which divides a line segment joining 2 points in the ratio m:10 or some other ratio. So, if you are known with the ratio and the coordinates of the endpoints of the line segments, you can find the coordinate of the point P by the section formula. The coordinate of a point P which divides the line segment joining x1, y1 and x2, y2. 2 points are given, x1, y1 and x2, y2. To find the coordinate of the point P, the condition is that it divides internally in the ratio m:10. Internally means the point P lies in between or in internal part of A and B, that is internally. Externally means that the point P lies outside the line segment AB. So, it has that another formula. External division has another formula. We are going to study about the formula for internal division. So, the coordinate of the point P can be found out by using the formula. You already studied about that. M x2 plus n x1. M into x2 plus n into x1 divided by the sum of the components of the ratio, and the second coordinate is m into y2, that is the y coordinate, plus n into y1. M into y2 plus n into y1 divided by m plus n. This is the section formula for to find the coordinate of the point P. So while doing problems, I think it is easy if you can draw the figure and looking at that and do rather than by hurting the formula. Come to a question. Find the coordinate of the point which divides the join of -1, 7 and 4, -3. Read the question, you need to draw a figure like this. Find the coordinates of a point P, I am going to mark it as point P, which divides the line segment joining the points -1, 7 and 4, -3. Two coordinates are given, -1, 7 and 4, -3. In the ratio 2:3 internally, the division is internal division and the ratio is given as 2:3. By section formula we have bisection formula. The point P equals, at first we can write the x coordinate. The point P is 2 into 4 plus 3 into minus 1. 2 into 4 plus 3 into minus 1 divided by 2 plus 3. And the y coordinate will be 2 into minus 3 plus 3 into 7. 2 into minus 3 plus 3 into 7 divided by 2 plus 3. The same section you studied on class 10th. Therefore, the point P is, or the coordinate of the point P is, the coordinate of P is, what is 5 by 5? 1, 15 by 5 is 3. So, this is the answer. Next one, the midpoint formula. How to find the midpoint of the line segment joining the points A and B having coordinates x1, y1 and x2, y2. Given P is the midpoint, we need to find the coordinate of the point P. Since P is the midpoint, definite that it divides the line segment AB in the ratio 1:1. Why? Because as P is the midpoint, the ratio will be equal. Applying section formula, we can see that the coordinate of the point P is 1 into x2 plus 1 into x1. 1 into x2 plus 1 into x1 divided by the components 1 plus 1. The same way, 1 into y2 plus 1 into y1. 1 into y2 plus 1 into y1 divided by 1 plus 1. So, the midpoint formula states that 1 into x2 is x2, x2 plus x1, or you can write as x1 plus x2 divided by 2 and y1 plus y2 by 2. This is the formula for to find the midpoint of a line segment joining the points A and B. Next formula is area of a triangle. How to find the area of a triangle when 3 vertices are given? Area of a triangle whose vertices are ax1, y1, bx2, y2 and cx3, y3 is, you have studied about this area equal to half into modulus of x1 into, when taking x1, you need to consider x1 into, then you need to consider y2 minus y3. Take the order in cyclic way. This is cyclic order. Starting from A, then B, then C, in that way. So, half into x1 into y2 minus y3, plus, after taking x1, you need to take x2 into, as per the cyclic order, x2 into y3 minus y1, plus, the last coordinate is the coordinate of C, that is x3 into, if you take x3, which are the y values? y1 minus y2. Taking in the cyclic way, that seems to be very important. So, this much within the modulus value. This represents the modulus value, means that area never becomes negative. Area never becomes negative. Let's do a problem based on how to find the area of a triangle when 3 vertices are given. Find the area of a triangle whose vertices are 4, 4, 3 minus 2 and minus 3, 16. I draw a triangle with vertices as 4, 4, 3 minus 2 and 3 minus 3, 16 as vertices A, B and C. So, I need to find the area of triangle ABC equals. Without writing the formula, I am going to do directly. Half into modulus of, the next is within the bracket x1. A you need to think as x1, y1. The coordinate B you need to think as x2, y2, and the coordinate of C you need to think as x3, y3. So we are going to do directly half into x1 means 4 into go in the cyclic way A to B, B to C, then C to A. x1 into y2 minus y3. What is y2? y2 is minus 2 minus y3 is 16 plus x2 is 3 into when taking x2 you need to subtract y3 minus y1. What is y3? y3 is 16 minus y1 is 4 plus the last term is taking x3. x3 is minus 3 into when taking x3 you need to subtract y1 minus y2, that is 4 minus 2, 4 minus 2. Then close this bracket, don't forget to put the modulus symbol. Equals half into, we can simplify this modulus of within the bracket 4 into minus 2 minus 16 is minus 18 plus 3 into 16 minus 4 is 12 plus minus 3 into, so this the first term, this one the second term, minus 3 into 4 minus 2, that is 4 plus 2, 6. Okay, close the bracket, put the modulus symbol. Equals half into modulus of 18 into 4 is 72. So minus 72 plus 12 into 3, 36 plus minus 18, that is plus minus 18 is minus 18. Equals half into modulus of, what is minus 72 and minus 18? Minus 72 minus 18 gives minus 90. Minus 90 plus 36 will come within the modulus value. Equals half into, within the modulus you have minus 90 plus 36 gives 10 minus 6, 4, 8 minus 3, 5. So minus 54. Equals half into modulus of minus 54 when comes to get plus 54. Why? Because area never becomes negative. That is why we put the modulus symbol. Half into 54 equals 27. The unit of area is square unit. So the answer is area equals 27 square units. The application of area of a triangle, formula for to find the area of a triangle is finding the area of a quadrilateral when 4 vertices are given. So for to find the area of a quadrilateral with vertices x1, y1, x2, y2, x3, x4, y4, we need to draw a diagonal connecting either BD or AC. In one diagonal you need to draw so that the quadrilateral get divided into two triangles, as triangle 1 and triangle 2. Find the area of the first triangle by applying the area formula x1, y1, x2, y2 and x4, y4, and then find the area of the second triangle by using the coordinates B, C and D. Add up these two areas, you will get the area of a quadrilateral. So the application is finding the area of a quadrilateral in which area of quadrilateral ABCD equals, what you want to do, equals area of triangle ABD plus area of triangle CBD. Area of triangle CBD. A very important note. To test whether given points are collinear, you need to find the area of a triangle ABC. For example, when finding the area of a triangle ABC, suppose 3 coordinates are given. When finding the area of the triangle ABC, if the answer is equal to 0, it means that a triangle can't be formed. When finding the area, if the answer is equal to 0, it means that there isn't any area. Means that the 3 points lie in a straight line. Hence, for to test whether the 3 points A, B and C are collinear, you need to test whether the area of triangle ABC equal to 0. If it is equal to 0, then the points A, B and C are collinear. A very important note. The base of an equilateral triangle with side 2A lies along the y-axis such that the midpoint of the base is at the origin. Find the vertices of the triangle. A very important question. Consider a triangle ABC given that it is an equilateral triangle with side 2A. Means that the length of all the three sides AB equal to BC equal to CA. All are equal to 2A units. But the condition, the base AB lies along the y-axis with the condition that the midpoint of the base is at the origin. The midpoint of the base, let O be the midpoint of the base and let the midpoint lies at the origin. So that the total length of the side 2A gets divided into this much now becomes equal to A and the remaining A will come here. So that A plus A becomes 2A. The total 2A comes from this part, that is AO equal to OB, both are equal to A units. As per the given condition, the midpoint of the base is at the origin. Now you are asked to find the vertices of the triangle. The three vertices you need to find. Look at the point A. Here the point A is in the y-axis. Any point in the y-axis has its coordinate 0 and I need to find the y coordinate. Here also the point B is a point in the y-axis. Any point in the y-axis has its coordinate 0 and the y coordinate I need to find. What is the y coordinate now here? The point A lies A units above the x-axis. So the y coordinate is A. So the coordinate of the point A is 0A. And the point B is A units below the y-axis. Therefore, the coordinate of the point B is 0 minus A. You know why the h is equal to 0? Because the point lies in the y-axis. Both the points A and B lies in the y-axis. Therefore, the h coordinate equal to 0. Now, the only vertex you need to find is the vertex C. Let us start. Let ABC be the triangle. ABC be the equilateral triangle with side 2A. That is with what are the sides? AB equal to BC equal to CA. All are equal to 2A units. By the given condition, you can say that AO equal to OB. AO equal to OB. Both are equal to A units. Why? Because O is the midpoint of AB. Now, the coordinate of the point A equals, as the point A lies in the y-axis, its x-coordinate is 0 and it is A units above the x-axis, so the y-coordinate is A. Similarly, the coordinate of the point B is, the coordinate of the point B equals, the point B also lies on the y-axis, so its h-coordinate is 0 and the y-coordinate is A units below the y-axis, so it is minus A. Now we need to find the coordinate of the point C. Now, it is clear that C lies on x-axis. Can I say why? Why C lies on x-axis? Why? Because we studied that in an equilateral triangle, the perpendicular from the vertex bisect the opposite side. So clearly CO is perpendicular to AB. It is clear that C lies on the x-axis because perpendicular from the vertex perpendicular from the vertex of triangle ABC bisect the opposite side. Bisect the opposite side. Therefore, CO is perpendicular to AB. CO, or the line which is perpendicular, you know that AB is a line which lies in the y-axis. So, the line which is perpendicular to the y-axis will be the x-axis only. So, C lies on the x-axis. That is very clear for you. So, CO is perpendicular to AB and C lies on x-axis. That is clear for you. If C lies on x-axis, any point in the x-axis has its y-coordinate 0. You need to find the x-coordinate alone. You get a clear idea. What about the coordinate of the point A? The point A is it is in the y-axis, so the coordinate is 0, A. At any point the y-axis has its x-coordinate 0, and the point B is also in the y-axis, so its x-coordinate is 0, and it is A units below the x-axis, so it is minus A. Now you know that the point C lies in the x-axis as this line is perpendicular, because y and x-axis are only the perpendicular lines in this figure. And you know well that from the vertex, if you draw a line to the midpoint of the base in an equilateral triangle, then definitely that it will be a perpendicular line. Now our aim is to find the coordinate of the point C. That only remains here. For to find the coordinate of the point C, I am going to consider this right triangle. In a right triangle AOC, I am applying Pythagoras theorem by Pythagoras theorem. Hypotenuse square. In the triangle, which is the hypotenuse? The hypotenuse is AC square equals the base OC square plus the altitude OA square. The base OC square plus the altitude is AO square or OA square. You know that O is the origin, hence its coordinate is 0, 0. Now I am going to substitute the values. AC square. AC is actually the side of the equilateral triangle which is given in the question as 2A. So AC square becomes 2A the whole square equals OC. OC you need to find. So keep it as OC square plus AO is known to as A unit, so it is A square. Simplifying, we get 4A square equals OC square plus A square, which implies OC square equals 4A square minus A square, that is 3A square. 4A square here plus A square comes to the left side, becomes minus A square, so 3A square, which implies OC equals square root of 3A square. 3 has in any root, it comes out as root 3 itself, A square comes out of the root, you get A. But remember, plus or minus will come in a square root. Therefore, OC can be taken as plus root 3A, or you can think OC as minus root 3A. Remember, if the point C lies in the positive direction of the x-axis, I can take the value of OC as plus root 3 only. OC, this distance is plus root 3A. The point lies in the x-axis, hence its y-coordinate is 0, and this much x distance obtained to us root 3A. Plus root 3A. Now we have a doubt when we need to apply minus root 3A. Instead of drawing the vertex on the right side of the x-axis or on the positive direction of the x-axis, suppose if you draw the triangle in this way, with AB falls on the y-axis and the vertex C lies on the negative side of the x-axis, then OC you need to take it as minus root 3a, so that the coordinate B minus root 3a 0. So this is also possible, but as per our figure we need to take the coordinate as root 3a 0. But at last you must write the possible values are, therefore the coordinate of C is, the coordinate of C, third vertex, the coordinate of C is, we need to write like this, either plus root 3a 0 if it is on the right side of the x-axis or on the positive side of the x-axis, and minus root 3a 0 if it lies in the negative direction of the x-axis. So both are possible. So based on the figure we need to take it, but at last when finalizing you need to write that the coordinate of C. C has two possible values, either root 3a 0 or minus root 3a 0. Therefore you are asked to find the vertices of the triangle. Therefore the vertices of triangle ABC are, what about the vertex A? 0A. The vertex B is 0 minus A, and the last vertex applying Pythagoras theorem obtained for us as C equals plus or minus root 3a, 0. Come with another question. Find the distance between Px1, y1 and Qx2, y2. You know how to find the distance between Px1, y1 and Qx2, y2. But two conditions are given when the first case is PQ is parallel to the y-axis, and the second question, the line PQ is parallel to the x-axis. We need to draw the figure based on the question. At first you need to find the distance between Px1, y1 and Qx2, y2. Find the distance between Px1, y1 and Qx2, y2. We have the distance PQ equals root of x2 minus x1 the whole square, the distance formula, plus y2 minus y1 the whole square. Take this as equation number 1. Consider case 1 in which what is given for you, the line PQ is parallel to y-axis. PQ is parallel to y-axis. When two lines are parallel, the distance between them, now this is the y-axis and this is the line PQ. When two lines are parallel, the perpendicular distance between them will be same everywhere. The distance between them will be same everywhere. Means that the distance of the point P from the y-axis will be the same as the distance of the point Q from the y-axis. Since PQ is parallel to y-axis, what you can say? Distance of P from y-axis, distance of the point P from y-axis, that will be equal to distance of Q from y-axis. Distance of Q from y-axis. But you know that in a coordinate, the distance of the point P from the y-axis will be the x-coordinate. The distance of P from the y-axis is its x-coordinate x1, which is equal to distance of the point Q from the y-axis. This much distance. This distance is x2. So x1 equal to x2. Take this as equation number 2. From 1 and 2, or you can think of substituting 2 and 1. From 1 and 2 we have, if x1 equal to x2, it implies that x1 minus x2 will be equal to 0. This is actually equation 2 itself. A modified form of equation 2, that is x1 equal to x2, means that x1 minus x2 will be equal to 0. This I am going to substitute in equation 1. Therefore, equation 1 becomes PQ equals root of, you substitute x2 minus x1 as 0. So 0 square is 0 plus y2 minus y1 the whole square equals square root of y2 minus y1 the whole square only remains. So the answer is y2 minus y1. So the answer of the first question is the distance PQ equals y2 minus y1 when the line PQ is parallel to y-axis. Come with case 2. When PQ is parallel to x-axis. Given the line PQ is parallel to x-axis. If the line PQ is parallel to x-axis, the perpendicular distance between these two lines will be same everywhere. Means that the distance of P from the x-axis will be the same as the distance of Q from the x-axis. That I am going to write here. Therefore, distance of P from x-axis, distance of P from x-axis is the same as distance of Q from x-axis, distance of Q from x-axis. Both are same. What is the distance of P from x-axis? The distance of P from x-axis is this much height, which is equivalent to the y-coordinate y1 equals distance of Q from the x-axis. For any point, the distance from the x-axis is its y-coordinate, so y2, which implies y1 minus y2 will be equal to 0. Take it as equation number 3. This equation 3 I am going to substitute in 1. Therefore, from 1 and 3 or equation 1 becomes PQ equals root of x2 minus x1 the whole square plus replace the y1 minus y2 or y2 minus y1 equal to 0. So the answer equals root of x2 minus x1 the whole square, which implies PQ equals root of x2 minus x1 the whole square. When comes out, you get x2 minus x1. So this is the second case in which the line PQ, when parallel to the x-axis, the distance PQ will be equal to x2 minus x1, subtracting the h coordinates. And the same way, when the line PQ is parallel to y-axis, to find the distance PQ, you need to subtract the x coordinates around. Come with one more question which you studied in class 10th. Find a point on the x-axis which is equidistant from 2, minus 5 and minus 2, 9. All these questions as well as all these concepts we need to have for the chapter straight line. Find a point on the x-axis. You need to find a point in the x-axis. So, let P be the point in the x-axis. Let P be the point in the x-axis. You know that any point the x-axis has its y-coordinate 0. So I am going to take the coordinate of the point P as y-coordinate 0 and let the h-coordinate be x. Let P be x0. What is given for you? You are given that the point on the x-axis is equidistant. Equidistant means that equal distance. PA, the distance PA and PB are equal. Let A be the point 2, minus 5 and B be the point minus 2, 9. Take the point A 2, minus 5 and B as the point minus 2, 9. What is given for you? Given they are at equal distance means that PA equals PB. The distance PA equal to PB. How to find the distance PA? Taking this as x1, y1, this as x2, y2, you can find PA as well as PB. Now I am going to find PA. PA equals root of x minus 2 the whole square, or if you want you can write as 2 minus x the whole square. x minus 2 the whole square plus 0 minus minus 5. 0 minus minus 5 the whole square equal to. The distance PB is root of PB. One unit take as x1 by 1, the other unit to take as x2 by 2. So distance PB equals to root of x2 minus x1 the whole square. So x minus minus 2 the whole square plus 0 minus 9 the whole square. Okay, we can simplify, that is root of x minus 2 the whole square plus 0 minus minus 5 is 0 plus 5, 5 square is 25 equals root of x plus 2 the whole square, minus of minus is plus, plus 2 the whole square plus minus 9 the whole square is 81. Next simplification is I am going to expand it or squaring both sides. Squaring we get both the sides, the root get rid of. So x minus 2 the whole square plus 25 equals x plus 2 the whole square plus 81. This I am going to expand by means of a minus b the whole square. A square minus 2 into a into b, that is 4x, plus b square is 4 plus 25 equals a plus b the whole square. A square plus 2ab plus b square, 2 square is 4 plus 81. Next piece, the like terms you know to cancel on both sides. Plus x square you can cancel on both sides, and 4 and 4 as well as cancel on both sides. The remaining is therefore minus 4x plus 4x comes to the left side becomes minus 4x. So minus 4x equals this 4x comes to the left side becomes minus 4x. Your right side is 81 plus 25 comes to the right side becomes minus 25. So minus 8x equals, this becomes 11 minus 5, 6, 7 minus 2, 5, 56, which implies x equals 56 by minus 8 equals minus 7. X equal to minus 7 means that the point P is minus 7, 0. Therefore, the point P, the required point P is minus 7, 0, which is equidistant from the given 2 points. Thank you. Note down the homework questions.